begin looking at software and hardware interaction. So here we're looking how the hardware and software interact. Be able to explain how the program works, how a software program works, track software development, just basic flow chart, compare an application with a system software, what's the difference, be able to compare those, and how software is distributed, the 3-4 ways that can be distributed. And there's your vocabulary words. I'm not going to run over each one of those. I'll let you do that. Basically, inputting the way that software programs are primarily written are at the keyboard and with a mouse or some tablet perhaps to graphically input. There are Visual Basic, Visual Lisp is another one. That they call it that because you can kind of graphically create software routines using a graphic system. Okay, a graphic kind of input, and they've come a long way with all that. We're not even approaching how we create apps for the smartphone. That's another whole discussion. So, understanding the role of the software, it's basically the programming code, instructions to instruct the hardware and then receive input from the user. Okay? So, instruct the hardware a little bit and then wait for input, or it waits for input and then instructs the hardware. So it's a sharing back and forth between the human interface and the hardware. So they interact and process the data, which data is what? Numbers, text, labels, that type of thing, alphanumeric. Remember, a computer can only count to 1 and then must start over. Okay? Because it uses the binary system. It just counts from 0 to 1. That's all it can count to. So the commanding the hardware to count from 0 to 1, okay, there's a machine language, and then there is software that interacts with the machine language that then interacts with the actual physical registers in the processors that count to 1. Okay? Very fast. Millions of times a second. So we do this by using an algorithm, clearly defined logical steps. Big fancy word for a set of steps, okay, that are logical, okay, to solve a particular problem that we've come across. In your textbook, you'll read about an example. Any of you read chapter 6 yet? Looked at it? Looked ahead? Anyway, doing laundry. Okay? How to do laundry. There's a step or procedure for that. Of course, a lot of us make it up on the fly, but if you have to instruct somebody how to do it, then you're going to give them a list of steps to do it by. So, the problem is you got dirty clothes and you want clean clothes, so you make up a list of steps and you teach somebody how to do laundry. So that's an algorithm, the list of logical steps. So a programmer writes software, and every step has to give an explicit instruction. Of course, there are notations. There could be graphics involved along the way, but every step is a specific, explicit instruction. Nothing is wasted. You don't have fluff in there. Okay? then a specialized computer program translates that language into a machine language, okay, that it understands. Has a few basic microprocessor commands. Any of you in here had microprocessors here already? Okay, didn't know if any of you had taken that yet or not. Digital. Okay, so in there you would learn about that. There's just a few commands to that you use. Push and pull, and copy and delete. And so pushing registers up, it's like flipping switches. Because remember, it counts to 1. 0 is off, 1 is on. 0 is 0 voltage, 1 is 5 volts. Okay, so it flips the switch on and flips it off. Okay, instead of it being a physical light switch, which that's what kind of the original computer kind of was, you know, big switches, gigantic. All right, it's microprocessors and solid state type of switches using electronics, using the physics of the electricity to do that. So you could have an algorithm for averaging a set of numbers, for example. So you would have these 8 steps, let's say. It could be more steps, possibly, but at least 8 steps here. So you would start out by telling the machine that, okay, over here is A, and it's going to be 50. Here's B, and it's going to be 144, and C is going to be 68. There's a whole bunch of other steps, of course, for input and for translating, storing it in certain registers and putting it over here and putting it over there and all that. But this is the basic steps, the algorithm. Then we're going to use a math function and add those together. Then we're going to let the sum of A, B, and C equal some other variable, okay, like X. Then we're going to divide X by 3. Well, there's probably another step or two in there where we would actually count the numbers, the quantity of numbers that we're averaging, so we can come up with the number 3 that we're going to divide by. Then we let the quotient equal Y. Then we would print the text to the screen, the average is, and then we would have the value of Y show up. Okay? So you're doing this kind of all these steps. If you were asked to average those numbers, you know, on paper or with your calculator, you would probably be doing those steps. So a software program solves the problem of averaging the numbers and does it over and over again anytime you ask for it. Okay, it's always there. So next we look at tracking software development. Software development is a multi-step process. Okay, there are literally, you know, towers of people or towers, buildings that are towers, multiple stories of programmers in these big software companies, and that's all they do is write code. Okay, I don't really know about like the Word application software, or word processor, or Excel, but like AutoCAD software that you're going to learn how to use. 10 years ago, I was told that it had over 1 million lines of code in the software that were compressed into the exe file that starts it up, that runs it, and it's on in several other locations, of course, but it's 1 million lines of code. Okay, that's a lot to keep track of, you know, and it amazes me that they can even track it and keep it up to date and know what's going on. You know, that's a lot to keep up with. All right, that's if you print it out in step by step, you know, longhand form. Okay. So it's multi-step, and when someone recognizes the need to perform a task more effectively using a computer, then we do software development. The flow chart is pretty simple. I mean, it can be very much more complicated than this, or complex. So essentially, the beginning, we've identified a problem, so we start in the development, and we go to design. We design it how it's going to appear, how it's going to interact, you know, the basic look of it, feel of it. Then people get started on writing the code in a language, whatever it might be. Then they go through testing. Then errors show up. Yeah, I have an error. Is it a design error? No. Well, then it jumps back up in here, and it must be a code. Is it a design problem? It's just really not, you know, it's the program's working, but it's just the design of it and the look and feel of it is just not there. So it goes back into design department, okay, into the flow. Could be any number of people involved, probably few people at the beginning with the design, and then numerous people involved with the coding. Okay. Then it goes through that process. Once it's working as solving the problem and don't have a lot of errors, then it goes into a beta test. And they call this the beta test. They'll have on their list a cross-section of users out there in public, and they get some advanced copies to try out. AutoCAD or Autodesk, the parent company of AutoCAD, does this every release. And a lot of book publishers, authors, get beta copies. And they go ahead and start writing books, you know, for the new software releases. And they'll have bugs in it, but they'll go ahead and do the book. And then sometimes we've had books come out and it's based on the beta version. It's got bugs in it. But at any rate, the beta test is done, and before it's finally released to the general public. Okay, when we compare application software and system software, okay, basically application helps you perform a specific task and runs inside the operating system, okay, your system software. So Windows operating system, the Mac operating system are two examples. Linux, okay. So applications run up underneath that. So more specifically, your application software is like your Microsoft Word, okay, for a word processor. Your database systems, which would be Microsoft Access, example. Presentation would be PowerPoint, like what I'm using right now. Spreadsheet would be your Excel. Your graphic design programs like AutoCAD, or to some degree Publisher, Microsoft Publisher, and many others like Adobe has a lot of that, graphic design, Maya, other types of packages. And Autodesk has other things in graphic design, numerous, probably 20 different types of software programs available, application software, that do various types of graphic design. And then, of course, application software could be like Blackboard, and the personal software that you use for, I don't know, ancestry research, other things for your home management. Multimedia software, okay, work group computing software, where It allows a work group to work as a team on similar, on one package or on one particular project. So when we use application software, there are customizations available inside of there where you interact with it and can change the way it looks yourself as a user. Modify a lot of the way it looks and what functions are available to you on a default basis. AutoCAD, for instance, even offers you the ability to write program and really change the way it looks totally, automate all kinds of functions, and if you're really good at it, you know, you can get pretty far up in a corporation or an engineering or architectural firm doing that kind of work. Okay, so the application software can be customized and modified, and one example is the quick access toolbar that's up in the top of any Microsoft or Windows-based type of application software. Most of it has the ability to customize at least that. And then AutoCAD, you can write your own code, you can write your own commands. It's pretty amazing. Not very difficult to learn either. Your system software then, the group of programs that coordinate, control all the resources and operations of your computer. Your operating systems provide the interface between the user or application and the computer hardware. Then we might have included with that utilities and language translators, which is pretty awesome how far along that's developed nowadays. So to maintain the computer hardware or other software, usually perform a single task. Okay, utilities, just one little thing: clean the hard disk, change the video screen resolution. Lots of little utilities. All right, now how we actually are allowed to use the software. So when you buy software, you buy the license. You do not own the code. You do not own, you might still buy a disk, but almost everything is downloaded now, you know, from all these application software companies. All right, so you really don't ever have anything physically in your hand, you know, because we used to think, oh, you know, I bought this software, you know, I own this software. No, you just own the license. You just paid for a license to use it. That's it. That's the only right you have, is to use it, but you don't own the code or anything. All right? So a software license gives you permission to use the program. Single user is what most of us are involved with. Then there's network license, which we have here at organizations and schools and companies and so forth. Be a network license. Okay? And the program is installed on a server and then distributed over the network. And more and more it's becoming where, you know, it sets on the server and you really don't have the majority of the application software on your hard drive physically. It's out there. And so it's on the server, it's on the cloud, it's from the actual software company themselves, and they just parse out what you need to get up and running for the application you're doing. And then when you close it, all that goes back off of your computer. You don't really have it. It doesn't really sit there and it's not residing. If any of you use Google Drive, any of you? So Google Drive, it has this type of software distribution, okay, that comes through their web application. So you can operate and use spreadsheets and word processors and everything that they have, and it's right there. And when you create a document, it updates like that. But I don't physically have the software on my computer. When I log into my Google Drive, the software is available there. Okay. We used to call it time sharing operation, a TSO, and it was awful years ago. 30 years ago. Taught a programming class using Fortran in a time sharing operation with big old terminals, and it was so slow. Anyway, identifying options continued. We can, if we have the license, we have the software purchased, then you will be sometimes sent a software patch, okay, that goes over top of the software you've already owned or that you have installed, and fixes a whole bunch of things all at once. Okay, you can have an update that would be a whole bunch of files to revise the software and fix bugs. Okay, so boy, doesn't Windows like to do that? If you've used a computer any, you know, they're constantly annoying you with updates. And like my really old Neanderthal system I have back there at my old gateway tower, every now and then I'll hook it up to the network, and the guys in IT really don't like me to hook it up too often. So anyway, I hook it up, and it's got like, you know, 130 updates that it wants to do, you know, to the Windows operating system. So it'll sit there and just run and run and run, you know. But it's about reached the end of its useful life, okay? Because I think it's like, I don't know, 15 years old or something, 15, 16 years old. But it does run, doesn't have Windows 7 on it, but it still runs. The guys just don't like me hooking it up. Anyway, an update just fixes the bugs. Then a service pack is a whole bunch of, it's updates and fixes and enhancements. Okay, so you got just a patch, fix a few things. Okay, an update, fix a few more things, and updates it a little more aggressively. Okay, and some enhancements. And service pack, it's like almost getting a whole new, it could be so many things, it's almost like a whole new piece of software. Okay. Alright, so upgrades are revised versions. Talked about that already. Well, updates. Then an upgrade is a whole revised version. Okay, so about every 2 years I upgrade my AutoCAD software in here. So getting ready to do that in the spring. Web applications like Google Drive I just talked about can be used on all operating systems. That was not always the case. Now, I don't think the book goes back into history on that any, and you're not going to need to know it. This is just nice to know. You know, when there was a big battle between Internet Explorer, Microsoft and Internet Explorer, and I believe it was Mozilla who was really invented the web browser. They were the first, one of the very firsts. And so Internet Explorer or Windows, they only ran, Windows only ran Internet Explorer. You really couldn't put another browser in there easily. You could, but man, it was awful. So there was a big lawsuit, and Microsoft lost, and they had to allow, it was default. You know, when you installed Windows, I think it was like on Windows 95 where it started, it was default, and it was like getting into Fort Knox And in some cases, you really just couldn't do it. It was just going to really make it unusable. Okay, and sometimes you get the Internet Explorer out and you couldn't get it back in. So at any rate, that all changed, and so now we're able to run all kinds of browsers on the Windows systems. So they didn't have a big monopoly on it, and it's been good. So we access these applications through a web browser or over a network. It could be an intranet. You're not really going outside the building. You're using an intranet. It could be an application that runs in a browser and it's on the server in the building, in your confines, or within the corporation, not necessarily in the building, but it's not accessible by anybody outside of the corporation or military. Alternative methods then, there's open source. I mean, you can actually open it up and look at the code. Okay, there's freeware. Beware of freeware. Okay, offer it to you free. It's got all kinds of little Trojans in there and different things, to cause you havoc. Be sure that it's certified wherever you download it from. That it has some statements or has some qualifying statements on there that say that it's free from virus and so forth, but still, I don't trust them. Shareware, which is like freeware, but they kind of would like for you to pay them something. A little more reliable. And then bundleware, which a whole bunch of applications comes inside of one piece of software. All kinds of different applications bundled together. We use one here called Master Suite for AutoCAD, Autodesk. I have about 9 different packages of software that come as a bundle. Okay, then there's software piracy. You don't hear about that as much as you used to. They've really got the stuff locked down pretty good. Autodesk, gosh, they've gone through everything you can imagine, for protecting their software. And now, I mean, the way it is now, they give it away free to students and to schools. And for several years now, I mean, you have to give them all kinds of information before they give you their software. And you got to have a key, software key, to make it run, just like Microsoft kind of does the same thing. So without that key, and it only works with that installation, and it's serialized to your particular computer, so it's more and more difficult to pirate the software. Alright, so hardware is anything you can touch, the piece of hardware. Software, you can't really touch it. It doesn't have any substance, so it's code, it's written instructions. So they interact with the computer to process the data. The computer processes the data by applying the rules called algorithms that somebody put into the software. It begins when someone recognizes, software development begins when there's a problem that we want to solve, and a computer can do it. The programmer breaks it down into an algorithm. The programmer works out logical steps, and then works through a flow chart. Depends on how complex that chart is, on what data we need to really create and process. So we use a specific language, we call it, programming language. It has a lot of controls over how the lines of code are written, specific terms, and a thing called syntax, the order, and the type of character it's expecting, a syntax. Then it translates it into a language the computer can understand. So software development requires quality control, running systematic tests, beta tests, and so forth. There's two types of application software. Two types of software, the application and system software. Your operating system is your interface between you, the user, and the application and the hardware. When you purchase software, you purchase a license. It can be a single license. It can be a network license. It can be a license on the web. And that concludes a look at software and hardware interaction. Are there any questions? Any part of that you want me to clear up? Go back over? Anybody in here do any programming? Ever? Okay. It's really not difficult to learn how to do. I like it because it's organized and you just follow the steps for what you want to do, and it will work. If you want to use the computer in a greater way to solve a problem for you or to use it to make something. Okay. All right.